we want to prove the product rule of derivative. That's the derivative. I should have written prime there. Derivative of f times g is f prime times g plus g prime times f. Okay, the function is a product f times g, and we are finding the derivative d over dx, or we could have written prime. Recall the definition of derivative. Suppose y equals, let me write down uppercase f, then the derivative f prime x or d over dx of fx, same thing. That's just simply the limit h goes to 0 of our function is uppercase f x plus h minus fx over h. In any case, that's the rise over run slope of the second line, and we are making this run very, very small, make h goes to 0. That's how we find the derivative. Okay, in this question, this product is our function f. Okay, so let's use this definition. Then in this case, using the definition, the derivative f prime of x, or we could have written d over dx of fx, is given by limit h goes to 0 f of x plus h minus fx over h. Okay, that's from the definition, provided this limit exists, which is same as limit h goes to 0 h minus fx is this product, just fx times gx. Okay, this f is a product of f and g. Same thing here. Now f of x plus h would be same thing, fx gx, but x is replaced by x plus h, so this would be f of x plus h times g of x plus h. Okay, now we want to evaluate this limit. If we replace h by 0, we are going to get 0 over 0. When h is 0, this is fx times gx minus same thing, so 0 over 0. So we need to simplify before we plug in h equals 0. Since f and g are just not given explicitly, so we need to do something on the top. As you know, let me recall, this is for uppercase f. If we have lowercase f, just lowercase f, lowercase f. If it's g, then it's g. So I want to write down, I want to add and subtract something on the top, then you will see we will have the definition of f, lowercase f and lowercase g. So I want to f of x plus h g x plus h. I want to subtract something. Okay, I want to subtract f x g x plus h. You will see in a moment. And this one is not there, so I want to add same thing, fx g x plus h. Okay, if we this is negative, this is positive, so if we cancel, we are back in the original. So we are basically adding 0, which is allowed, minus the last afx gx. Now I want to group these 4 terms in 2, first 2 and last 2, and from the first 2 terms on the top we can factor gx plus h out. So this is f of x plus h minus fx once we factor gx plus h out, gx plus h, plus on these last 2 terms I want to factor fx out. So I want to write that again, fx here, then what is left, gx plus h minus gx, and everything over h. Now I want to separate that h here. I want to write h here over h plus over h. Okay, just splitting into two fractions. Now I want to take the limit, and if you look at closely, how about this limit? F of x plus h minus fx over h when h goes to 0. It matches with this definition. Okay, fx plus h minus fx. We had uppercase f here. Okay, that was uppercase f. But if we replace uppercase f by lowercase f, then that will be lowercase f prime of x. So we have the same situation here. This whole fraction, when we take this limit, it goes to, this thing goes to f prime of x. And when we replace h by 0, then this becomes gx. And this limit is for this fraction as well. And same thing like this one. If we replace this uppercase f by g, we would get g prime of x. So this one goes to g prime of x, and fx, there is no more h. So in fact, when we take this, when we distribute this limit to first fraction plus another fraction and take this limit, this is gonna go to f prime of x, and when we replace this h by 0, we get gx plus this is g prime of x, and this is fx, and that is what we were trying to prove. And in fact, this adding, subtracting and adding gives us the right fraction to get this derivative.